Okay, this is video number 6. It is the last part of section 11.4 in your book, and it deals with the same pictures you saw on the last part of the lesson where we were talking about angles, except this time we're talking about the lengths of their segments and finding segment measures. And I thought it was a good idea to break this into 2 different lessons. So if you'll take a look at this one, the vertex is on the inside of the circle there where you have 2 chords that intersect. Okay, so the rule to figure this out is you're going to have 3 of the measurements given and 1 you're going to be missing. But the rule is each part, you can multiply them together and set it equal to the other chord, if you will. So A times B is equal to C times D. And that is the first theorem. A times B equals C times D. Okay, so you just multiply the pieces. You can figure out the missing measurement. Pretty simple. The next one is, I got a little funny story about this one. The first year I taught this, I taught it wrong and didn't realize it until a little bit later. So, I kept looking in my book and why is my book wrong? But anyway, it wasn't the book. Needless to say, it was me. So I'm going to try to give you some helpful hints on this one. But if you'll notice, this is the one where you've got your vertex outside of the circle. We have 2 secants. And the rule's similar to the last picture, except we don't multiply A and B and C and D, which is what I was doing incorrectly my first year teaching. You actually do the outside part times the entire length there, your entire secant, if you will. So it would be B times not A. You would have to get the entire segment. So I'm going to add this. This is a little different than what your book has. So I'm going to put an E out here. And I'm going to mark out the A. I don't need it. I need the outside times the entire thing. Same thing for the other one. So instead of D times C, I'm going to put an F to represent the entire secant. So it's going to be the outside times the whole thing. B times E is equal to, on the other secant, D times the whole thing, which is F. D times F. Okay? And I'll actually, in fact, let me do it now. Let me give you an example that has actual numbers in it. So here is a problem. This actually goes along with example 3A on page 610 of your book. Okay, so if you'll notice, you've got 2 secants where the vertex is outside of the circle, and you've got 3 of the numbers, and you've got 1 Y that's missing. Okay, the common mistake, which is what I messed up on my first year teaching, was do 7 times Y equals 6 times 8, and that is incorrect. We need the outside times the entire thing. So for the top one, it would be 6 times 6 plus 8, which is 14. I'm going to mark out the 8, and I would suggest you do that too, especially on your worksheet. Figure out the entire thing and mark out the part you don't need so you don't use it by mistake. If this part is 7, the entire thing would be 7, not 7Y, but 7 plus Y. So be careful there. And we wouldn't need the part inside. So the formula or the equation then would be 6 times 14 equals 7 times 7 plus Y. And then you could distribute and solve that for Y, and you should get 5. Okay, so I wanted to give you an example that had numbers in it. And the last theorem is very similar to what we just did, except instead of having 2 secants, you've got 1 secant and a tangent. So if you use the rule the same way, you wouldn't do B times C, you would do B times the entire thing. So I'm going to put a D right there instead, if I can write a D upside down. Okay, so this would be the outside times the whole thing, B times D, equals. Over here you've got A is the outside, but the whole thing is A as well. So if you think about outside times the whole segment, that would be A times A, or A squared. Okay, so when you have a secant and a tangent, you square the tangent. So outside times the whole thing, B times D equals A squared. And I think another little heads up is when you work some of these problems on your worksheets, your worksheet 9-7, and then also maybe some of the ones out of your book. You have squares, which means you might have to do things like factor. So you may have some quadratics, so set everything equal to 0 and factor it. And remember, your measurements can't be negative. So in this case, you would eliminate any negative segment lengths, unlike algebra where you had negative answers sometimes. And that takes care of the rest of 11.4 on finding missing segment measures. We only have one short lesson left, and we'll do that next time, and that's about actually putting some graphs or circles on graphs.